1915, the Clement Talbot factory grounds, Barlby Road, West London. A short walk from Wormwood Scrubs prison. A vehicle rolls out of a workshop. It sits on a luxury car chassis, clad in thin grey steel, with a Vickers machine gun bolted into its nose. The radiator grille is still there, unchanged, the kind you would see parked outside a Mayfair hotel. The tyres are road tyres, the same as any gentleman's touring car, but none of that is the strange part. At the rear of the vehicle, mounted on an open steel frame above the tail, spins a 4-bladed propeller. The engine driving it is not a car engine, it is a 110 horsepower Sunbeam aircraft power plant, the same type fitted to aeroplanes, turning a propeller more than 6 feet across. The entire rear assembly is exposed, unarmoured, open to the air, spinning. It looked insane. It looked like someone had dismantled an aeroplane and bolted the engine to the back of a car, then called it a weapon of war. It would never fire its gun in anger. It would never cross the desert it was built to conquer. It would never leave England. Within weeks of this single trial on a London athletics ground, it would be cancelled, shelved, and quietly forgotten, leaving behind almost nothing except 2 photographs and one of the most spectacular engineering failures in the history of British military vehicles. Its name was the Sizaire-Berwick Wind Wagon, and it was the most absurd armoured vehicle Britain ever put on wheels. To understand why the Wind Wagon existed, you need to understand the crisis the RNAS Armoured Car Division faced in 1915. The Royal Naval Air Service Armoured Car programme had been created in 1914 under Winston Churchill, then First Lord of the Admiralty. The original concept was practical and effective. Naval pilots stationed in France needed fast armed cars to rescue downed airmen before German patrols reached them. It worked brilliantly in the opening weeks of the war, when the front was still fluid and roads were still usable. Then the trenches came. By the end of 1914, the Western Front had locked into stagnation. Armoured cars were useless against trench lines, but the war was spreading. Britain needed mobile firepower in places where there were no trenches at all. Palestine, Mesopotamia, the deserts of North Africa, wide, open, featureless terrain where speed and range mattered above everything else. And in those places the problem was not barbed wire, the problem was sand. Conventional wheeled vehicles sank into soft desert sand, tyres spun, drive shafts torqued against nothing. Vehicles bogged down and died. An armoured car in a sandpit is simply a stationary target. The RNAS needed a solution, and someone proposed one that was, on paper at least, not entirely unreasonable. A propeller, mounted at the rear of the vehicle, would push the car forward through air alone. The wheels would still contact the ground and steer, but propulsion would come from thrust, not traction. Sand cannot stop a propeller. A propeller does not need grip, it simply pushes. The idea had precedence. French engineer Lieutenant de Lafargue had tested a propeller-driven vehicle called the Sauterelle between 1912 and 1914, reportedly reaching over 50 miles per hour on smooth surfaces. Belgian inventor Marcel Léa had been building propeller cars in Paris since 1913. Glenn Curtiss in America had experimented with the concept as early as 1906. The principle was understood. In outline, the engineering was proven. What made the Wind Wagon British, and what made it a vehicle of this particular moment, was geography and convenience rather than inspired design. The RNAS Armoured Car Division maintained its repair and experimental workshop at the Clement Talbot Works on Barlby Road, practically next door to the Park Royal factory of the Sizaire-Berwick Company. The company's co-director, a man named Alexander Keeler, was both the heir to the Keeler Marmalade fortune and an RNAS officer who had transferred to the Armoured Car Division in December of 1914. The factory was there, the connection was there, the need was there. Someone made the proposal. Someone approved it, and a Sizaire-Berwick luxury car chassis found itself being fitted with a second engine and an aircraft propeller. The Sizaire-Berwick Company itself was a Franco-British luxury automobile venture founded in June 1913. It paired the Sizaire brothers, Maurice and Georges, gifted French engineers who had previously won the 1906 Coupe de Voiturette and the 1907 Targa Florio, with Frederick William Berwick, a London-based car importer. Their flagship product was a 20-horsepower touring car built around a 4-cylinder engine displacing 4,070 cubic centimetres, capable of 45 miles per hour, designed for English country roads and fashionable driving. It was not designed for combat. It was not designed to carry armour. It was emphatically not designed to have an aircraft engine bolted to its tail. The vehicle that emerged from the Park Royal workshop presented every contradiction at once. At the front, the standard Sizaire-Berwick 20-horsepower engine remained, its civilian radiator still in place, suggesting that whatever engineering alterations were made to the chassis, the original drivetrain was retained. The armour plating added around the crew compartment was mild steel, not hardened armour of the kind used on purpose-built military vehicles. It measured approximately 4.2 millimeters thick. This offered adequate protection against shrapnel fragments at distance. Against rifle fire at any reasonable range, it would offer the crew little more than psychological comfort. To make matters worse, the armour nearly eliminated the forward windscreen entirely, leaving the driver with almost no direct line of sight ahead. The wheels, the axles, the entire drivetrain, and the propeller assembly at the rear were completely unarmoured and exposed. Every moving part that kept the vehicle mobile was available to any enemy soldier with a rifle. At the rear, the Sunbeam Crusader 110 horsepower aircraft engine drove a four-bladed propeller with shortened tips. The tips had been reduced specifically to decrease the risk to crew and bystanders from the spinning blades, though the protection offered by this modification was partial at best. A guardrail surrounded the lower arc of the propeller, but the blades themselves remained dangerously close to anyone moving near the rear of the vehicle. The propeller was mounted on an open steel frame, angled slightly upward to provide some downward thrust and prevent the nose from lifting under acceleration. The sole weapon was a single Vickers water-cooled machine gun in .303 caliber fixed into the front armour plate. Its field of fire was severely limited. Traversing the gun far to either side was impractical. There was no turret. There was no rotating mount. The crew consisted of 2 men, compared to the 3 or 4 who operated a Rolls-Royce or Lanchester armoured car. The vehicle weighed approximately 4 tons. Now, before we get into what happened when the Wind Wagon was actually taken outside and tested, if you are enjoying this deep dive into British military history, hit subscribe. It takes a second, costs nothing, and helps the channel grow. Summer 1915. Wormwood Scrubs, West London. The crew started both engines. The Sizaire-Berwick 20 horsepower unit turned over at the front. The Sunbeam Crusader thundered to life at the rear. The four-bladed propeller began to spin. The noise was immediate and extraordinary. Aircraft engines of that period were not designed for quiet operation. Mounted at the rear of a light vehicle with no sound insulation whatsoever, the Sunbeam Crusader produced a roar that carried for a considerable distance in any direction. This was not a vehicle that could approach an enemy position undetected. This was a vehicle that announced its approach from far enough away to allow an enemy unit to observe it, discuss options, take up defensive positions, brew tea, and still be ready when it arrived. Then the propeller began to bite. A column of dust erupted from the ground behind the vehicle, sucked into the propeller arc and blasted forward and sideways in a choking cloud. The crew at the front found themselves inside a machine they could barely see out of, behind armour that had nearly eliminated their windscreen, surrounded by grit thrown back by their own propulsion. On a London running track, this was a serious inconvenience. On desert sand, the same effect would have generated a dust column visible for miles, rising into the sky like a signal fire advertising the vehicle's exact position to every enemy observation post in the region. No formal test report has been located, but the problems revealed that day did not require a document to be obvious. The vehicle could not reverse. A propeller mounted to push in one direction has no reverse gear. If the Wind Wagon drove into a ditch, a wall, or an enemy position from which it needed to extract, it had no ability to back away. Conventional armoured cars used reverse constantly, to reposition after firing, to extract from soft ground, to withdraw from contact without exposing their rear. The Wind Wagon's 2-man crew could only go forward or stop. The propeller and the Sunbeam engine were completely unarmoured. A single rifle round into the engine block would silence the propulsion entirely. A round through a propeller blade would set up violent vibration. The blade would likely shatter or detach, and fragments would pass through the rear of the vehicle. In any combat environment, every enemy soldier within rifle range would have an obvious, unprotected, and immediately decisive target to aim at. Then there was the sand itself, the entire reason the vehicle existed. French experiments with propeller vehicles had demonstrated years before this trial that desert sand destroyed propeller leading edges. The constant abrasion of sand particles against spinning wooden blades stripped them within hours, reducing thrust and generating vibration until the propeller became useless. The vehicle's own solution to the sand problem would have been destroyed by the sand it was trying to cross. The exposed Sunbeam Crusader would have inhaled that same sand. Aircraft engines of this period carried no air filtration adequate for desert operation. Grit in the cylinder bores causes rapid wear. The engine that was supposed to push the car through terrain hostile to conventional engines would have been consumed by that terrain faster than any conventional engine. Beyond all of this, the civilian chassis had been built to carry passengers. Whether it was structurally reinforced to absorb the combined weight, vibration, and mechanical stress of 2 engines, armour plating, and an aircraft propulsion unit remains unknown, because no engineering records have surfaced. What can be said is that the vehicle was never designed with those loads in mind. Lieutenant Commander McGrath and his team at the experimental workshop did not need a lengthy evaluation to reach their conclusions. The cancellation came quickly and without ceremony. The Sunbeam Crusader engines were needed for actual aeroplanes. The program had consumed resources, produced one vehicle, and the vehicle had failed at its only trial without leaving London. It was shelved. The prototype was presumably scrapped or dismantled. Only 1 or 2 photographs survived, taken at Wormwood Scrubs, showing the vehicle static and with the propeller turning. Those images appear today in books cataloguing the world's worst weapons. The Wind Wagon's failure becomes precise when measured against the armoured cars that actually went to war. The Rolls-Royce Armoured Car was the Wind Wagon's exact contemporary and its total opposite. It weighed approximately 4.7 tonnes, built on a luxury car chassis just as the Wind Wagon was. But there the similarity ended. The Rolls-Royce carried 12mm of purpose-built rolled steel armour, nearly 3 times the protection offered by the Wind Wagon's mild plate. Its Vickers machine gun sat in a fully rotating turret, capable of engaging targets in any direction without turning the vehicle. Its crew of 3 or 4 could extract from difficult ground using reverse gear. It was mechanically reliable and could be maintained by competent mechanics using standard tools in field conditions across 3 continents. T. Lawrence, who fought alongside Rolls-Royce armoured cars throughout the Arab campaign in World War I, called them more valuable than rubies in the desert. They served from France to Gallipoli to Libya to Iraq to the Irish Civil War. Some remained in active military service as late as 1944, 30 years after the first prototype was built. They did not need a propeller. They simply drove. The Lanchester armoured car told a parallel story. 3 RNAS squadrons took their Lanchesters to Russia, where they covered more than 53,000 miles across mountains, deserts, steppes, and near-Arctic conditions between the Caucasus, Persia, and Romania. Full turret, multi-man crew, genuine armour, reliable engine. It worked because its fundamentals were sound. Against these vehicles, the Wind Wagon's failure was not merely technical, it was philosophical. The Rolls-Royce and Lanchester succeeded because their designers started with what a vehicle needed to survive and fight, then built outward from that requirement. Protection first, reliable propulsion second, usable weapons third. The Wind Wagon started with a clever idea, a convenient factory, and a luxury car chassis that happened to be next door to the workshop, then tried to bolt combat capability onto a framework never designed to carry it. The propeller concept itself was not absurd in isolation. The logic of thrust-based propulsion on soft terrain was real, and engineers returned to it for decades. The Germans in North Africa during World War II actually mounted a propeller engine on a captured Bedford truck, specifically to generate dust storms that concealed troop movements from Allied observation. Propellers on ground vehicles had genuine tactical applications, but the Wind Wagon attempted to make a propeller into the primary propulsion system of an armoured fighting vehicle without solving a single one of the ancillary problems that made armoured vehicles survivable. It solved none of the things that mattered and introduced several new problems that had not previously existed. After the program ended, the Sizaire-Berwick Park Royal factory did something the Wind Wagon never managed. It contributed to the war effort. The works pivoted to genuine military production, manufacturing Lerone aero engines and building de Havilland bombers. The workforce grew to 5,800 employees. The brothers whose name was on the factory never returned to armoured car work. Maurice Sizaire survived the war and continued designing vehicles for years afterward. Georges Sizaire served throughout the war as President Poincaré's personal driver for frontline visits, which presents an irony that deserves a moment's reflection. While Georges chauffeured the French head of state to the trenches, his company's luxury chassis was being fitted with an aircraft engine and propeller in a London workshop. He was part of the war. The Wind Wagon never was. The company struggled commercially after the armistice. A receiver was appointed in October 1920. Herbert Austin gained a controlling interest by 1923. British production ceased by 1925. The company faded from the record. The Wind Wagon had already faded long before, 1915. Wormwood Scrubs, West London. A 2-man crew sits inside a thin steel box on a luxury car chassis, with an aircraft engine spinning a 4-bladed propeller behind their heads, on a London running track, wrapped in a cloud of their own dust. The vehicle could not reverse. Its armour would not reliably stop a rifle bullet. Its propeller would have been shredded by the sand it was designed to cross. Its engine would have choked on the same sand. Its noise advertised its position for a mile in every direction. Its machine gun barely moved. Its crew had almost no forward visibility, and yet the men who built it were not fools. They were engineers facing a genuine tactical problem, under pressure to solve it quickly, in a workshop next to a factory that had a suitable chassis on the shelf, and a shared connection through an officer who held a stake in both organisations. The propeller concept had been tested in France, had reached 50 miles per hour on smooth ground, and the logic in a meeting room in 1915 before anyone took the thing outside was not obviously wrong. What the Wind Wagon demonstrates is not stupidity. It demonstrates the difference between an idea that works in outline and engineering that works in practice. In military design, sound fundamentals do not yield to clever concepts. A vehicle that cannot reverse, cannot protect its crew, cannot survive its own operational environment, and cannot approach an enemy undetected is not a weapon. It is a demonstration of what happens when urgency and convenience replace rigour. The Rolls-Royce Armoured Car went to war, the Lanchester went to Russia, the Wind Wagon went to the scrapyard. One was insane. One was British.